Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good afternoon to all of you. So guys, we are going through fluid mechanics and we have done some really good amount of work till now. We are already aware Eulerian-Lagrangian approach. We are aware about local changes, convective difference. We are aware about what is fluid, concept of continuum, and we are into fluid properties. So last time we were discussing density, which we have completed. We have done the discussion of bulk modulus also, and some portion of bulk modulus is done, which I would like to complete now. And once the bulk modulus is over, we will talk about viscosity. Yes, the definition of viscosity we have already done in what is fluid. We will quickly revise that definition and we will majorly focus on the effects of viscosity, that is boundary layer formation. हमारे syllabus में the definition of viscosity which is required in our syllabus that we have already discussed. So if you have not done it, if you have not seen the video of what is fluid, please watch it. It will help you out. ठीक है ना? So I think firstly, let us quickly start the portion which we left last time. So let us quickly discuss that portion of bulk modulus. And all those people who are watching the video for the first time, अगर आपको वीडियो पसंद आएगा और आपको अच्छा लगेगा मुझसे पढ़ के, तो do like us, subscribe us and help us share these videos with your friends also. तो मैं एक फ्लूइड मैकेनिक्स का कोर्स एग्जीक्यूट कर रहा हूँ और ये कोर्स थोड़ा लंबा चलने वाला है, एवरी डे ऑन ऑल्टरनेट डे बेसिस. तो आप रोज 2 से 3:30 बजे एवरी डे फ्रॉम 2 to 3:30 PM यू कैन फोकस ऑन फ्लूइड मैकेनिक्स. Tuesday, Thursday, Saturday, you can do with me the work with me. And Monday, Tuesday and Friday, you can revise the same work. And the remaining part of your day, you can dedicate to your other subjects. Since these videos are getting stored in the playlist, so you can directly access the playlist. Last time students were telling कि एक दो video playlist में add नहीं हुआ है, so I will tell the team and ask them to do it. ठीक है? So I think let us start with the bulk modulus part. Let us start with the bulk modulus part. Just एक मिनट, मेरा पेन नहीं चल रहा है, ठीक है? And I can observe there are some students online. So kindly do reply wherever you feel a doubt. So guys, last time what we saw? Last time we saw bulk modulus, है ना? So bulk modulus says suppose there is a change of suppose there is a substance. And that substance has an initial volume V. Now on the substance, there is a change in pressure. So what will happen? We can find out the change in volume of substance and that will be minus V dP by K. What does minus sign represents? Minus sign represents if the pressure will increase, the volume will decrease. So when dP is positive, dV has to be negative. The same formula can be written in other form also, where there is a change in density. That change in density is equal to initial density into change in pressure by bulk modulus. And we saw some questions, है ना? We saw 2-3 numericals over there. Hi Sachin, क्या हाल है बेटा? I hope everything is going well. So I saw you were there in that session also. So that session was so Ashutosh, he's a graduate from UPSC Petroleum Engineering and he did his preparation by self. तो मुझे लगता है कि कभी कभी छोटी छोटी बातें होती है जो पता लग जाती हैं. तो अगर आपको कुछ सेशन में यूजफुल रहा हो तो मुझे भी बताना और अपने फ्रेंड्स के साथ भी शेयर करना. ठीक है, चलो काम स्टार्ट करते हैं. So last time we discussed some questions and I think these were the questions that we discussed. So our first question of bulk modulus, I think this was the question of bulk modulus we discussed. This is a very basic question of IES, definition based question of IES, है ना? So this is how the question was. Which one of the following is the bulk modulus of a fluid? So we know that d rho is equal to k dp by d rho is equal to rho dp by k or k is equal to rho dp by d rho. है ना? This we already have done. Similarly, there was a question when corresponding to change in pressure, there was a change in density. So again, they were asking you the bulk modulus. So this question also we have done, and we found out that the answer is 250 megapascal. So change in density is given, d rho is given, dp is given, initial density is given. You have to find out the bulk modulus. Hana, we have done this question. And then there was a question where we saw what is compressibility. We saw compressibility. Hana? So compressibility is the opposite of bulk modulus. Bulk modulus is how difficult it is to change the density of substance. And compressibility is how easy it is to change the density of substance. Okay? Acha. Now, before moving any further, I would like to discuss one point which I forgot the last time. Okay? So what you can do, you can write a note. So, Sachin, beta, what is the density of water? What is the density of water? Yes, obviously, or you will say 1000 kg per meter cube, है ना? Let me do one thing. Let me write the actual density of water at 1 atmosphere and 20 degrees Celsius. So at 1 atmosphere, 20 degrees Celsius for water, the density is 998 kg per meter cube. How do we know this? We can make this value out from the graph that we discussed last time. So density can be written as 998 kg per meter cube. Okay. Now consider that the bulk modulus. So bulk modulus of water, which is quite a decent value for water. I mean, this is almost the true value for water. So the bulk modulus is 2.1 gigapascal. Let us assume the bulk modulus of water is this much. Okay. Now do one thing. Assume that the pressure on water changes from 1 atmosphere to 101 atmosphere. So this is like 100 times change. The pressure has changed 100 times, almost 100 times. So what I will do, I will find out the change in density. I know you guys can also do it. You guys also do it, and I will also do it. What we will find out? We will find out how much is the change in density. So I think when I say change in pressure, so change in pressure is written as final pressure minus initial pressure. So 101 atmosphere minus 1 atmosphere. I think this will become 100 atmosphere. This is the change in pressure. So when we are trying to find out the change in density, that will be the initial density 998 kg per meter cube into change in pressure, which is 100 atmosphere, upon bulk modulus, which is 2.1 gigapascal. So 2.1 into 10 raised to power 9 pascal. Now please note, change in density is in kg per meter cube. Initial density is in kg per meter cube. The upper term, pressure term, is in atmosphere. Bottom term is in pascal. So you need to have the terms in same units. So what I will do, atmosphere I will convert in pascal. How? So 1 atmosphere is equal to 101.325 into 10 raised to power 3 pascal. ठीक है ना? देखो क्या होता है? 1 atmosphere is a unit of pressure. So Indian Ocean, Atlantic Ocean, Pacific Ocean, है ना? They have the same sea level. So you can say at 0 sea level, when the temperature is 15 degrees Celsius and there is no storm, then the pressure of atmosphere on 0 sea level is 101.325 kilopascal. So this particular value, we are calling it as a unit. क्या होता है कि 0 सी लेवल पे जब टेम्परेचर 15 डिग्री सेल्सियस हो और कोई तूफान ना हो, तो जो एटमॉस्फेरिक प्रेशर की वैल्यू होती है वो 101.325 किलो पास्कल होती है. तो हम उसी वैल्यू को यूनिट का नाम दे देते हैं. ठीक है. नाउ कैलकुलेट मी हाउ मच इज द चेंज इन डेंसिटी. Who will find out how much is the change in density? Let me also calculate. So Sachin is giving us some value. So let me take the value of Sachin only. I'm not calculating. I'm taking the value of Sachin because it is almost correct. Almost correct. So change in density is 4.75 kg per meter cube. So what will happen? What is the initial density? Initial density is 998 kg per meter cube. How much is the new density? So if I call this value as 5 kg per meter cube, so the new density will be 1003 kg per meter cube. This means when the pressure becomes 100 times means 10,000%. When the pressure increases by 10,000%, the density changes only by 0.5%. Are you getting the point? When the change in pressure is 10,000%, the change in density is only 0.5%. That's why the change in density is so small that it can be ignored. So we can consider the change in density 0. So density is almost constant. That's why we consider that water is incompressible. Whenever you have a substance which has a high bulk modulus, then even for large change in pressure, it is very difficult to change the density of substance, and the density of substance will remain nearly constant. So when we talk of solids and liquids, when you talk of solids and liquids, their bulk modulus, they are of the order of gigapascal. Their bulk modulus are of the order of gigapascal, 10 raised to power 9 pascal, which is very large value. So when there is a change in pressure, the change in density is very small. So you can say the density is almost constant, even though there is a change in pressure, but the change in density is almost zero, density is almost constant. So we will treat the substance as incompressible. Okay? So it's not like that the change in density is exactly zero. Change in density is there, but it is ignorable. So there is no substance which is perfectly incompressible. Change in density is always there, but that change in density can be small. But when you talk of gases, the bulk modulus of gas is of the order of 10 raised to power 5 pascal. It is very less. Therefore, change in density is significant. D rho is significant. That's why we call gases as compressible. हम gases को compressible बोलते हैं. Yes or no? All of you kindly check. Is it correct or not? Kindly check. Is it correct or not? Sachin and anyone else who is watching the video, please do let me know. And if this is clear, then I would like to move on to the next question. Okay, so I'm moving on to the next question. So this is a question from ISRO. One thing is there, I think I have wrongly mentioned the year. I don't think it is from 2012. Maybe the year is something else, but the question is from ISRO. Okay? Now check what the question says. Question says a reservoir of capacity 0.01 meter cube. So there is a reservoir which has this much volume, is completely filled with a fluid of coefficient of compressibility this much meter square per Newton. So I think coefficient of compressibility beta C is given. So beta C is given as 0.75 into 10 raised to power minus 9. And this is meter square per Newton, SI unit. So when I will write the bulk modulus, that is 1 by beta C. So 1 by 0.75. So 1 by 0.75 is 4 by 3. And 10 raised to power minus 9 will go up. This will become 10 raised to power 9 Newton per meter square. So bulk modulus or coefficient of compressibility is given. Now they are asking the amount of fluid that will spill over. So amount of fluid that will spill out. If the pressure in the reservoir is reduced by 2 into 10 raised to power 7 Newton per meter square. I think they are saying that we will reduce the pressure in the reservoir. If you are reducing the pressure on the reservoir, the density of the fluid in the reservoir, it will decrease. Basically, the fluid will expand. And obviously, the container is open. That's why the expanding fluid is spilling out. Correct or not? Hai? So, check what we have. As per the question, what will be the situation? As per the question, there will be a container and container is open to atmosphere. Container is completely filled with some fluid. It is completely filled with the fluid. And on the fluid, there is some pressure. Okay. Now, what will happen? If they will reduce the pressure, the fluid will expand. And I think the increase in volume will fall out of the container. So when they are asking you how much the fluid will spill out, they are simply asking you how much will be the increase in volume. Hai na? So check what will happen. How will you write? You will say the change in volume with the change in pressure is given as minus VdP upon K. We already know what is the bulk modulus. We also know what is the initial volume of fluid. Initial volume of fluid is same as the volume of container. And we also know what is the change in pressure. So change in pressure is minus 2 into 10 raised to power 7 Pascal. Why minus? Because the pressure is decreasing. So what I will do, I will simply write change in pressure, which is minus 20 minus 2 into 10 raised to power 7 Pascal. Then we have bulk modulus. Bulk modulus is equal to 4 by 3 into 10 raised to power 9 Pascal. Then we have the initial volume, which is same as the volume of container, and I think it is 0.01 meter cube. So when the pressure will decrease, how much will be the change in volume? Minus VdP by K, the formula which we have already written. So this will become minus 0.01 into change in pressure, which is minus 2 into 10 raised to power 7. Now check, minus and minus will cancel out, denoting that the change in volume is positive. If the change in volume is positive, volume is increasing, है ना? And divided by bulk modulus. How much is the bulk modulus? 4 by 3 into 10 raised to power 9. Correct? Now I feel what will happen. I feel you can solve this. So dV is equal to 0.01 into 10 raised to power 7. That is 10 raised to power 5 divided by 10 raised to power 4. So I think there will be a 10 raised to power minus 4. Okay. And 3 into 2 will go up. 3 will go up. So this 3 will go up in the numerator. So when it will go up, 3 into 2 will be 6. 6 divided by 4 is 1.5. So this will become 1.5 into 10 raised to power minus 4. And since everything we have taken in SI unit, so answer will be meter cube. So this is the change in volume, increase in volume. Now whatever the volume of fluid is increasing, that will spill out of the container. So this is your answer. I hope the answer is clear to everyone. And if there is a doubt, please do let me know. Go through the question once and do let me know. एक बार देख लो फटाफट से क्वेश्चन. कोई दिक्कत हो तो बताओ. ऑप्शन चेक कर लें. ऑप्शन भी चेक कर लेते हैं. ऐसा ना हो कि ऑप्शन ही मैच नहीं कर रहा है. So where is the question? I think this is your answer. I think this is your answer. 1.5 into 10 raised to power minus 4. Very good, Akshay. Very nice. Totally correct, beta. Good. Very nice. तो ठीक है, चलते हैं नेक्स्ट क्वेश्चन करते हैं. सो अक्षय, यू हैव जॉइंड जस्ट नाउ. एक्चुअली सम पोर्शन ऑफ बल्क मॉडुलस वाज लेफ्ट लास्ट टाइम, तो बस वही कवर अप कर रहा हूं और फिर हम विस्कोसिटी चालू करेंगे. तो एक क्वेश्चन और कर लेते हैं, एक दो क्वेश्चन और कर लेते हैं, फटाफट से चेक कर लेते हैं. Actually, there are two good questions which I want to discuss. I have discussed those questions in regular class also. पर मैं सोच रहा हूं कि पहले थोड़ा सा विस्कोसिटी पढ़ लेते हैं, फिर हम वो दो क्वेश्चंस भी सॉल्व करेंगे. तो ये रहा नेक्स्ट क्वेश्चन, बेसिक क्वेश्चन. तो क्वेश्चन सेज द बल्क मॉडुलस ऑफ एन आइडियल फ्लूइड इज. नाउ व्हाट डू यू मीन बाय आइडियल फ्लूइड? What do you mean by ideal fluid and what is the answer of this? There are some options given to us. The bulk modulus of ideal fluid is 0, 1, infinite, none of the above. Who would like to give me the answer? अक्षय, सचिन, कोई भी. क्या आंसर आएगा? So what do you feel? What is an ideal fluid? Akshay, Sachin, बेटा जो लोग भी वीडियो देख रहे हैं, what is an ideal fluid? I think when you talk of ideal fluid will have a definition. So actually there are three terms in ideal fluid. Ideal fluid means, first of all, a non-viscous fluid. Non-viscous means the viscosity of the fluid is 0. So when the fluid will move, there will not be any friction, है ना? If friction is not there, there will be no dissipation of mechanical energy. Also, the fluid says that the fluid has no surface tension. So when the time will come, we will see what is the effect of surface tension. So fluid has no surface tension, and how we are going to define surface tension? By sigma s. Please note, sigma is the symbolic notation of normal stress. But surface tension is not normal stress. Very good, Sachin. Very nice answer. अक्षय, बेटा थोड़ा ध्यान से देखो, थोड़ा गड़बड़ हो गया. तो sigma s is equal to 0. But one more condition of ideal fluid is something which is perfectly incompressible. Something which is perfectly incompressible. What do you mean by perfectly incompressible? So perfectly incompressible means whatever is the change in pressure, it does not matter. The change in volume or change in density is going to be zero. Whether the change in pressure is large or small, it does not matter. The change in density is going to be zero. Now, how do you write change in density or change in volume? I think you can use this formula, right? Now, there is some value of density. There is some value of change in pressure. These values are non-zero. So, this value will be zero only when the denominator is infinite. For any change in pressure, the change in density will be zero when the bulk modulus is infinite. And you can write the answer by definition also. How? So, bulk modulus means how difficult it is to change the density of substance. And if the substance is perfectly incompressible, it is extremely difficult to change the density of substance. So bulk modulus is extremely high, infinite. So this way you can write the answer. I think simple question, simple answer, and in a similar manner, they might ask you what is the compressibility of an ideal fluid. So compressibility is the inverse of bulk modulus. So if bulk modulus is infinite, compressibility is going to be zero. So always remember, for an ideal fluid, these two terms are zero. But when you are talking of bulk modulus is infinite. Okay, bulk modulus is infinite. But compressibility is again zero. Okay, this is the definition of ideal fluid. Okay. Okay. So I think two more questions were there. Two very good questions were there. पहले थोड़ा सा पढ़ लेते हैं, ठीक है? And then we will discuss those questions. थोड़ा सा पढ़ लेते हैं आज के लिए और फिर हम उन क्वेश्चंस को डिस्कस करेंगे. इससे क्या होगा कि मैं आज का जो टाइटल है वो भी जस्टिफाई कर पाऊंगा, क्योंकि आज का जो टाइटल है वो विस्कोसिटी एंड बाउंड्री लेयर है. ठीक है, तो थोड़ा सा पढ़ लेते हैं and then we will discuss those questions. So you might ask me, sir, what are those questions? Those questions are this one. So what I will do, once this chapter is over, so I will run a practice session of the chapter. So in the practice session, we will do some questions of the entire chapter. So at that time also I will discuss these questions. Okay? ये questions आप देख सकते हो. These questions I gave last time also as a homework. Okay? So those who have not got these questions, they can take a photo and they can press the pause button and take a photo. I am going to the next slide. This is your second question. ठीक है, चलो फिर चालू करते हैं, आगे बढ़ते हैं, थोड़ा सा पढ़ लेते हैं. So the next property, the next point that I want to discuss is first of all related to bulk modulus only. Bulk modulus में थोड़ा सा theoretical point और है, and that is related to ideal gases. It's related to what? Ideal gases. Okay, so what you will do in your bulk modulus only, you will make a note regarding ideal gas. Now let us suppose that there is some amount of ideal gas which is initially at a pressure P and volume V, and there is a change in pressure and change in volume. Correspondingly, there will be a change in volume. Now I hope you remember that for an ideal gas, whenever there is a change in property, we will call it as a process. And in general, we can represent the process for a gas by this equation. PV raised to power n equal to constant. This means whatever may be the pressure and volume of the gas, the pressure and volume are going to follow this law. This product is going to remain constant only. If you will heat the gas, the pressure and volume will change. If you will compress the gas, the pressure and volume will change. But this product will remain constant. Okay. Now, what is N? N is called as Polytropic Index. N is called as what? Polytropic Index. And for isothermal process, what is the Polytropic Index? I know those people who have done thermodynamics, they can tell the value of N. I think when the process is isothermal, N value equal to 1. when the process is isobaric, n value equal to 0. Constant pressure process. When the process is isochoric, constant volume process, n approaches to infinite, है ना? And when the process is adiabatic, n is equal to gamma. N value is equal to gamma. So I hope you are aware of these values. ठीक है? So n value equal to 1. This is for isothermal process. This is for isothermal process. This means the properties of the gas are changing isothermally. Temperature is remaining constant. Pressure will change, volume will change, but temperature will remain constant. Similarly, this is for isobaric process, isochoric process, and adiabatic process. Last one is the adiabatic process. Okay, adiabatic process. I think it is hidden behind that slash. So adiabatic process. Okay, now you will ask me, sir, why you are doing this? Let us check why we are doing this. Actually, we are trying to find out the bulk modulus of ideal gas. What we are trying to find out? We are trying to find out the bulk modulus of ideal gas. So check, guys. So initial pressure is P, volume is V, and during a process there is a change in pressure. So this is the final pressure and this is the final volume, right? How do you relate PV? So PV raised to power n equal to constant. So this product is a constant. Now during a process there will be some changes. So changes are represented by derivative. But since this product is constant, so change of this product, that is the derivative of the constant, will be 0, है ना? भैया ये product constant है, so during a change the constant will remain the same, the product will remain the same, so there is no change in product. So what will happen? You can apply the product rule of derivation, differentiation. So you will say dp v raised to power n plus Pn Vn minus 1 dV, है ना? Derivative of V raised to power n, and this will be equal to 0. Now check. Very beautifully, this will become the formula of bulk modulus. How? Very easy. Check. Suppose this is x raised to power 6 and this is x raised to power 5. So what will happen? This power will cancel out, right? So you will have Pn dV is equal to minus VdP. If I take dV on the other side, what will happen? N into P is equal to minus VdP by dV. But bhaiya, minus dP upon dV by V, that is nothing but the bulk modulus. So what we have got? We have got the bulk modulus of ideal gas, which is equal to NP. So this is the bulk modulus of ideal gas, not for liquid, only for gas. Bulk modulus of ideal gas. सर क्या सिविल के लिए ये पॉइंट इंपॉर्टेंट है? नो, सिविल के केस में ये क्वेश्चन आए उसके चांसेस बहुत कम है. But sir, what about mechanical people? Yes, in case of mechanical people, this point is definitely very important. So write down bulk modulus of ideal gas. ठीक है? अब guys check. So what we have? Bulk modulus of ideal gas is given as n into P. What is n? N is the polytropic index. So basically, the bulk modulus of gas, it will depend upon the type of process. How the volume of the gas is changing. Whether it is changing isothermally, isobarically or adiabatically. ठीक है ना? Also, the bulk modulus of gas depends upon pressure, absolute pressure, है ना? So if the pressure of the gas will change, the bulk modulus will also change. ठीक है ना? So please remember, bulk modulus of ideal gas depends upon the pressure of the gas as well as the type of process undergone by the gas. ये बहुत important है. ठीक है? अब जैसे say for example, let us take a simple question. So there is a gas which has a pressure P1 and volume V1, and the gas is in closed container. Okay, closed rigid container. Gas is in closed rigid container. Okay. Now the gas is heated. So that the temperature of the gas becomes double. So when you are heating the gas, there will be a change in pressure, there might be a change in volume, and there might be a change in temperature, है ना? मतलब कि when we are heating the gas, there will be a change of properties. So what will happen? Pressure P1 will become pressure P2, volume V1 will become volume V2, and temperature T1 will become temperature T2, है ना? So they are saying we are heating the gas in such a manner that final temperature is twice the initial temperature. So they are asking you what is the final bulk modulus. Why they are saying final bulk modulus? They are saying final bulk modulus because the bulk modulus will change with the pressure. So if the pressure will change, the bulk modulus will also change. So they are saying find out K2, that will be NP2. है ना? So they are asking you how much is the final bulk modulus of the gas. Bulk modulus of the gas at the final state. So who would give the answer for this? कौन देगा इसका आंसर? चेक करें इसका आंसर क्या आएगा. दोबारा से मैं क्वेश्चन रिपीट कर देता हूं. हाय यश, हाउ आर यू? सो यश बेटा, आई होप यू आर वाचिंग द वीडियोस रेगुलरली. अगर आपको नहीं पता है तो आपको बता देता हूं, फ्लूइड मैकेनिक्स के लेक्चर चल रहे हैं कंटिन्यूअसली, और हर ट्यूसडे, थर्सडे, सैटरडे को लेक्चर होता है जिसमें हम 1.5 घंटा पढ़ते हैं. तो आप डेली का 1.5 घंटा अपना एफएम को डिवोट कर सकते हो. एक बार मेरे साथ वीडियो देख सकते हो, अगले दिन उस वीडियो को रिवाइज कर सकते हो, और आपका जो बाकी टाइम है वो आप अपने बाकी सब्जेक्ट्स को डेडिकेट कर सकते हो. तो इस तरह से हम एफएम को यूट्यूब पे ही कवर अप करेंगे. जितना हो पाया उतना कोशिश जरूर करेंगे. ठीक है, तो हम काफी सारी चीजें कर चुके हैं. ये वीडियो एक प्लेलिस्ट में सेव होता है, तो वो प्लेलिस्ट देख सकते हो आप स्टार्टिंग से, क्योंकि स्टार्टिंग से देखना बहुत जरूरी है, अदरवाइज आप कंफ्यूज हो जाओगे. अब जैसे आज मैं विस्कोसिटी के बारे में बात करूंगा, तो मैं विस्कोसिटी की डेफिनेशन पहले सिखा चुका हूं व्हाट इज फ्लूइड में, इसलिए स्टार्टिंग से जो लोग वीडियोस देखेंगे उनको बहुत फायदा होगा. So guys, check, very easy guys, very easy. Sir, there is a gas which is in a rigid container, closed rigid container. This means the volume of the container will not change. So volume of the gas will remain the same during the process, है ना? Volume of gas will remain the same during the process. So during the process, how much is the change in volume of gas? 0. This is only possible if the bulk modulus is infinite. Yes or no? So if someone goes by the logic, he can say, he or she can give the answer directly. He or she will say, this is a rigid container, the volume of gas during the process will not change. So change in volume is 0, which is only possible when bulk modulus is infinite. Or you go by the other method. We are talking of ideal gas. How do we write the bulk modulus of ideal gas? Polytropic index into pressure. So this is an isochoric process. What kind of process? Isochoric process. Why isochoric process? Because volume is constant, rigid container. So what will happen? For isochoric process, the n value is infinite. If n value is infinite, bulk modulus is also infinite. Okay? तो इस केस में गैस का बल्क मॉडुलस इनफाइनाइट आएगा. इस केस में गैस का बल्क मॉडुलस इनफाइनाइट आएगा. I hope this is clear to everyone and there is no doubt. I hope this is clear and no doubt is there. Okay? So like this, some questions will be there, and once we are done with the entire chapter, we will come back to the questions of all the topics, and we will see those 2 questions of bulk modulus, 1-2 extra question of bulk modulus, and some questions of bulk modulus regarding ideal gas. अब आज के टाइटल को जस्टिफाई करते हैं और आज का टॉपिक पढ़ते हैं. क्या है आज का टॉपिक? विस्कोसिटी एंड बाउंड्री लेयर फॉर्मेशन. So you can write down the topic that we are starting today. This is a lengthy topic and definitely it will take good amount of time. So topic name is viscosity and boundary layer. So I will denote the viscosity by this symbol. So this symbol is called as mu. Meow billy wala, mu. Similarly, there will be a kinematic viscosity. So kinematic viscosity will be represented like this. This will be called as new. नए कपड़ों वाला, new clothes. ठीक है? So basically the spelling are mu and nu. ठीक है? So there are 2 symbols. One is dynamic viscosity, one is kinematic viscosity. This one is dynamic viscosity. This one is what? Dynamic viscosity. So dynamic viscosity and boundary layer formation. Dynamic viscosity and boundary layer formation. ठीक है. So who would like to tell what is viscosity? कौन बताना चाहेगा viscosity क्या होता है? Sachin, Yash, Akshay, anyone who is watching the video, who would like to tell what is viscosity? In what is fluid, we have already seen the definition of viscosity. So any idea what is viscosity? सचिन ने तो मेरे साथ पढ़ा है, अलग से भी पढ़ा है. एंड सचिन आज हमारी क्लास भी है शायद, है ना, 5 o'clock. इफ आई एम करेक्ट, यू आर द सेम सचिन. आज हमारा क्लास भी है. रेजिस्टेंस टू फ्लूइड. रेजिस्टेंस टू फ्लूइड नहीं बेटा, रेजिस्टेंस टू फ्लूइड तो डेफिनेशन नहीं था. रेजिस्टेंस ऑफ लेयर्स ऑफ फ्लूइड. अच्छा ठीक है. Abhash is there. Very good, Abhash. Very nice. Very nice. Abhash, you were there in yesterday's class or not? कल की क्लास में थे क्या नहीं? कल यार पता नहीं मेरा ना मूड ऑफ हो गया था क्लास में. मतलब फ्रैंकली स्पीकिंग मेरे लिए ना क्लास का एक एक मिनट बहुत इंपॉर्टेंट होता है. मतलब मेरे लिए तो मेरा पैशन यही है ना, मेरी नौकरी भी यही है, पैशन भी यही है. तो कल क्या हुआ था, कल पता नहीं मेरा क्लास में मूड ऑफ हो गया था और फ्लो भी बिगड़ गया था. बट आई विल मेक इट आउट फॉर यू गाइस टुमारो. कल मैं इसको सब कवर अप कर दूंगा. ठीक है. कल पता नहीं, मतलब फ्रैंकली स्पीकिंग मेरा मूड बहुत ऑफ हो गया था क्लास में. Resistance of fluid to continuous deformation. Yes, we are getting the correct definition. So guys, if you remember, we always do a topic, and in this playlist also this topic is there. So what we did, when we were discussing what is fluid, we saw the difference between a solid and a fluid body. So you guys told me that there is a solid body. अच्छा, recorded देख रहा है आजकल, ठीक है, बट ये कंप्लीट जरूर करना. ठीक है, छोड़ना कुछ नहीं है. तो when you are talking of a solid body and you are talking of a fluid mass, so what we were doing, we were applying external shear stresses on the solid and fluid, and we were looking at how the two substances will behave. When you will apply external shear stress, how the two substances will behave. This we have already seen. So you guys told me that, sir, when we apply external shear stress on the solid, so depending upon the value of the shear stress, initially the solid body will deform, but the final shape will become constant. Once the final shape will become constant, the value of shear strain will be constant and the value of gamma dot will be 0. So I hope you remember this kind of situation. This is called as what? This is called as static deformation or continuous deformation. What is this called as? What is this called as? हमने क्या किया, हमने shear stress लगाया. We have applied a shear stress. Because of shear stress, there will be some deformation, but the final shape will be same. Final shape will be constant. Obviously, if I increase the value of shear stress, the body will deform further. If I decrease the value of shear stress, body will come back. But if the shear stress is constant, final shape is constant. So I think this was called as static deformation, है ना? So you were calling this situation as static deformation. So what did you guys tell me? You guys told me that, sir, when we apply shear stress on solid body, external shear stress on solid body, first of all, there is a static deformation. ठीक है? Secondly, since the body is deforming, there will be some internal shear stress. And the internal shear stress will be elastic in nature. And thirdly, the internal shear stress is directly proportional to static deformation, that is gamma. So what you say? Tau is equal to G into gamma. So you say there are two meanings of G. There are two meanings of G. So either we can write like this, tau is equal to G gamma, or we can write like this, gamma is equal to tau by G. So the first equation suggests that when there is static deformation in the body, then because of elasticity of the body, there is internal shear stress. So G value is the elasticity of the material. It is the property of material by virtue of which there is internal shear stress when there is a shear strain, when there is a static deformation. And the second equation says So first equation tells you internal stress. Second equation tells you external stress. So second equation says when we apply external stress, there will be a deformation. More is the value of G, less is the deformation. So G is the resistance to deformation. Which deformation? Static deformation. Now, in a similar manner, we explained for fluids also. So guys, those people who will watch the video for the first time, so I'm informing them, this discussion we have already done. So please watch the video of what is fluid and you will realize everything. तब आपको सारी चीजें पता लग जाएंगी. Hi Ravi, how are you? Nice to see you here. So Ravi, हम लोग viscosity डिस्कस कर रहे हैं. तो मैं वो चीजें रिवाइज कर रहा हूं जो मैंने व्हाट इज फ्लूइड में बताई थी एंड वी विल डिस्कस द इफेक्ट ऑफ विस्कोसिटी दैट इज बाउंड्री लेयर. Then for the fluid also we discussed something. So for fluid what we said, so Newton was performing an experiment, है ना? And Newton said when I will push the plate ahead, so I will push the plate ahead with a constant force. So I will observe that the plate is moving with a constant speed. So what will happen? Between the plate and the surface of water, there will be a shear force, right? So you guys made a conclusion that when there is a relative motion between a solid surface and adjacent fluid mass, when there is a relative motion between a solid surface and adjacent fluid mass, there is a shear force between them. Now we had to see what will be the effect of this shear force. So you guys told that what will happen within the fluid, we will observe a velocity profile. So those particles which are in contact with the solid plate, they will move with the speed of solid plate. And those particles which are at the bottom, they will be at rest. So we will observe a velocity profile. What do you mean by velocity profile? Velocity profile means continuous deformation. That is, the shape of the fluid will keep on changing with time. The final shape will not be constant. So here in fluids, we define a term gamma dot. है ना? Now what will happen? So you guys will say when we are applying external force, external shear stress, the fluid will deform continuously. And within the fluid, because of some property, internal stress will come into picture. So that internal stress is given as, it is directly proportional to gamma dot. But in our syllabus, gamma dot is equal to du by dy. है ना? I hope everyone remembers this. So what will happen? When you will remove proportionality sign, this will be equal to mu into du by dy. But what does du by dy represents? It represents continuous deformation. So you have to say when the fluid deforms continuously, then because of the property of the fluid, there will be internal stress. है ना? When there is a continuous deformation in fluid, because of property of fluid, there will be internal stress. What is that property? That property is viscosity. And we can also write like this. When we apply external shear stress, then because of the external shear stress, the fluid will deform continuously. But more is the value of dynamic viscosity, less is the continuous deformation. So dynamic viscosity is the resistance to continuous deformation. तो ये discussion हम पहले कर चुके हैं. Sir, is viscosity dependent on the density of the fluid? आभास ऐसा नहीं कहना चाहिए. हमें कहना चाहिए कि इनडायरेक्टली आपस में रिलेटेड है. फ्लूइड की जो डायनेमिक विस्कोसिटी और जो डेंसिटी है वो इनडायरेक्टली आपस में रिलेटेड है. कैसे? मान लो फ्लूइड के मॉलिक्यूल्स के बीच में डिस्टेंस कम है तो मॉलिक्यूल्स पास पास होंगे तो उनकी डेंसिटी ज्यादा होगी. मगर जो फ्लूइड की विस्कोसिटी होती है ना, वो कोहेसिव फोर्सेस पे भी डिपेंड करती है. तो अगर मॉलिक्यूल्स पास हैं तो डायनेमिक विस्कोसिटी भी ज्यादा होगी. समझ रहे हैं? तो कहीं ना कहीं जो फैक्टर्स डेंसिटी, थर्मल कंडक्टिविटी से रिलेटेड है, वही फैक्टर्स डायनेमिक विस्कोसिटी से भी रिलेटेड है. क्लियर है? all of you, anyone who had doubt in all this stuff? कोई भी ऐसा बंदा जिसको इस चीज में डाउट था? कोई भी ऐसा बंदा जिसको इस चीज में डाउट हो, प्लीज बता दो. हम ये ऑलरेडी डिस्कस कर चुके हैं. और अगर दिक्कत थोड़ा ज्यादा है ना, तो आप व्हाट इज फ्लूइड वाला वीडियो देखो, आपको जरूर क्लियर हो जाएगा. So guys, this discussion we already had. What was the discussion? That when we apply external shear stress, then the fluid will deform continuously. What do you mean by continuous deformation? So when we are applying external stress, the shape of the fluid will keep on changing with the time. The final shape of the fluid will not be constant. It will keep on changing with the time. And more is the value of dynamic viscosity, less is the value of deformation, continuous deformation. So we also know that dynamic viscosity is the resistance to continuous deformation. Dynamic viscosity is resistance to continuous deformation. ये हम लोग ऑलरेडी देख चुके हैं. और फिर मैंने ये भी एग्जांपल लिया था कि guys, what do you mean by deformation? What do you mean by deformation? Suppose there is an object and the object has 2 points, 2 particles, and the particles are moving with the same speed. So in that case, there will not be any deformation in the object. है ना? When this object is moving in a rigid manner, right? So if you take a particle, this particle and this particle, the distance between the 2 particles will remain the same. है ना? So basically the 2 particles are moving with same velocity. But if one particle is moving slow and other particles is moving fast, so distance between the particles will increase with the time. So basically the substance is deforming with the time. So when you say continuous deformation simply means that some particles are moving slow, some particles are moving fast. So basically there is a relative motion between adjacent particles. है ना? तो इसीलिए क्या होता है, कई बार ऐसा लिखा होता है resistance to relative motion between adjacent particles. Resistance to relative motion between adjacent particles. But the yellow color thing and white color bracket, they are the same thing only. सही है ना? सही है? Between adjacent fluid particles. All of you kindly check. I hope this is fine only. ये हम सब पहले डिस्कस कर चुके हैं. चेक कर लो, किसी को नहीं आता हो, पहले हम डिस्कस कर चुके हैं, इसलिए मैं ज्यादा डीप नहीं जा रहा हूं, मैं बस ऊपर ऊपर से टच कर रहा हूं. ऑल ऑफ यू करेक्ट है? ठीक है. सो इफ दिस इज क्लियर, देन लेट अस फोकस ऑन फॉर्मेशन ऑफ बाउंड्री लेयर, विच इज द मेन एजेंडा फॉर टुडे. आज का जो एजेंडा वो वही है कि बाउंड्री लेयर होता क्या है, व्हाट इज बाउंड्री लेयर एंड हाउ डज इट लुक लाइक. So to explain boundary layer, what we will do, we will take an example where there is a flat horizontal plate. So there are going to be some figures. So kindly draw the figures very neatly in your copies. Okay. So there is a flat rectangular plate is there. Okay. What we are doing, we are looking at the effect of viscosity, that is boundary layer formation. So we want to understand what a boundary layer is. So what I have done, I have taken a rectangular plate ABCD, and let me remove my video so that nothing is hidden behind it. Now I am assuming that over the plate, water is moving in X direction. Okay. Over the plate, water is moving in X direction. So what is X direction? So basically I will take a coordinate system over here. This will be the origin of coordinate system. D point will be the origin of coordinate system. This is the X direction. This is the Y direction perpendicular to the plate. And this is the Z direction. So if you will take any point whose coordinates are X, Y, Z. So what will be the meaning of Y distance? The meaning of Y distance will be the distance of the point from the solid surface. Distance of the point from the solid surface. Also, when you talk of AD side is called as leading edge. AD side is called as what? Leading edge. What do you mean by leading edge? It is the side of the plate where water approaches the plate. And the other side BC, this is called as trailing edge. This is the side of the plate where water leaves the plate. ठीक है ना? From here the water will leave the plate. So we will call this as trailing edge. Actually this terminology is important because in question in GATE exam it would be written like this. Find out the thickness of boundary layer at 10 centimeter from the leading edge. है ना? So you should know what a leading edge is. ठीक है, what are leading edges, what are trailing edges. So when you say x direction, when you say x coordinate of the point, x coordinate will mean the distance from the leading edge. Now always remember, so in overall the water is moving along the x direction, है ना? So x will be called as flow direction and y will be called as transverse direction. X will be called as what? Flow direction, and y will be called as transverse direction, flow or longitudinal direction. ठीक है, तो ये नोट कर लो, ये नोट कर लो. चेंज ऑफ वेलोसिटी विद रिस्पेक्ट टू टाइम. यस बेटा, वो तो लोकल एक्सेलरेशन होता है, लोकल चेंज होता है. आज हम स्टेडी स्टेट फ्लो मान के करेंगे. आज हम एजम्पशन लेके सॉल्व करेंगे कि फ्लो स्टेडी है. ठीक है, आज हम एजम्पशन लेंगे फ्लो स्टेडी है. ठीक है, ओके. नाउ गाइस, फॉर दिस वी आर गोइंग टू ड्रॉ अ 3D फिगर. So a 2D figure. So what I will do, I will look at the figure along the negative z-axis. So I will look at the figure along negative z-axis. So basically you will see the x direction and you will see the y direction. So for the plate, we are going to see the AB edge. So draw a big figure. ठीक है, बहुत बड़ा figure बनाना है, and if you can keep the copies in landscape mode, it would be better. So what we have, we can see the plate along the x direction. We can see the plate along the x direction, and we will see the A point of the plate. B point of the plate will hide behind A, and we will see the B point of the plate. C point of the plate will hide behind B. ठीक है ना? We will see this. We will see this. Now also draw a small 3D figure in the side. Draw a small 3D figure in the side also at the top corner. So in the 3D figure, this is your x direction, this is your y direction, and this is your z direction. Now whenever I say a cross section, तो जब भी मैं बोलता हूं क्रॉस सेक्शन, तो क्रॉस सेक्शन का मतलब होता है a section which is perpendicular to flow direction. So what is the flow direction? Flow direction is the x direction. So section will mean perpendicular to flow direction. So this is a cross section. This is a cross section perpendicular to x. Now obviously for this cross section you can write a distance which is x. For the cross section you can write a distance which is x. So whenever you say x, x means the distance of the cross section from the leading edge. Obviously for this side x is going to be 0. For this side x is equal to 0. And let me do one thing. Let me consider a cross section which is before the plate. So basically I am talking of a cross section where x is less than 0. समझ रहे हो ना आप? समझ रहे हो? सेक्शन का, क्रॉस सेक्शन का मतलब क्या होता है? क्रॉस सेक्शन का मतलब होता है एरिया विच इज परपेंडिकुलर टू फ्लो डायरेक्शन, दैट इज एक्स डायरेक्शन. तो मैं कहीं पे भी क्रॉस सेक्शन ले सकता हूं. तो मैंने क्या किया, मैंने क्रॉस सेक्शन को प्लेट से पहले ले लिया. नाउ ए बी साइड मीन्स एक्स इक्वल टू 0 and x is the forward direction, so you are taking a cross section in the backward direction. So for that cross section x will be less than 0. हाँ आभाष, अच्छा तो इसका मतलब बेटा परसों की वीडियो में दिक्कत आ रहा है ना, परसों के वीडियो में डाउट आ रहा है, लास्ट टू लास्ट क्लास. तो कहां पे डाउट आया? वैसे मैंने भी थ्योरेटिकली बताया, मैंने भी सिर्फ ऑर्डर ऑफ मैग्नीट्यूड ही बताया. तो अभी क्लास ओवर होती है तो 4-5 मिनट हम एक बार डिस्कस कर सकते हैं. मेरे को किसी का इंटरव्यू लेना है 4 बजे, तो वो अगर वो लिंक आ जाता है तो मैं अगर 4 मतलब मैं श्योर नहीं हूं कि मुझे इंटरव्यू 3:30 बजे लेना है या 4 बजे लेना है. तो अगर 3:30 बजे लेना होगा तब तो मैं चला जाऊंगा, बट अगर 4 बजे लेना होगा तो मैं प्रॉब्लम क्लियर आउट कर दूं. ठीक है, तो गाइस चेक. So what we have a cross section which is before the plate. So in 2D figure it will look like this. Actually what we are doing is we are making an assumption that as water is moving over the plate, then before water reaches the plate, the velocity at this cross section is uniform. What do you mean by this? By this you mean if you take any point on the cross section, the velocity on all the points will be same. If you take any point on the cross section, the velocity on all the points will be same. And I hope you remember what this figure is called as. ये फिगर क्या है? इस फिगर को क्या कहते हैं? मैंने क्या किया है? मैंने हर पॉइंट पे, सेक्शन के हर पॉइंट पे वेलोसिटी प्रोफाइल शो कर दिया है, वेलोसिटी वैल्यू शो कर दिया है. और मेरे ख्याल से इस तरह का जो 3D फिगर बनता है, इस 3D फिगर को हम लोग क्या कहते हैं? वी हैव ऑलरेडी लर्न दिस टर्म इन अवर क्या कहते हैं, मीन फ्लो वेलोसिटी एंड डिस्चार्ज. व्हाट डू यू कॉल दिस फिगर? क्या कहते हो इस फिगर को? आई थिंक इस फिगर को वेलोसिटी प्रिज्म कहते हैं, है ना? So here the velocity prism is a cuboidal shape. What kind of shape? Cuboidal shape. So I am assuming that before water reaches the plate, at the cross section velocity is uniform. So all these particles, they are moving with same speed, maybe 10 meter per second. How much speed? 10 meter per second. एक काम करता हूं, थोड़ा सा दोबारा से फिगर बना रहा हूं, नहीं तो थोड़ा सा हॉच पॉच हो जाएगा. जस्ट गिव मी अ मिनट. आई एम मेकिंग द फिगर लिटिल अगेन. So all these particles are moving with same velocity. How much is the velocity? The velocity is 10 meter per second. 10 meter per second. Let me call the bottommost particle as, क्या नाम दे दें? Let us call the bottommost particle as P. Second particle as Q, third particle as R, S, T, U. Okay, let us give this name to the particles. So right now all particles are moving with the speed of 10 units. So if all the particles are moving with the speed of 10 units, how much is the relative motion between P and Q? अगर सभी particles 10 units से move कर रहे हैं तो P और Q के बीच में relative motion कितना है? How much is the relative motion? Very good, Sachin. Correct answer. Abhash, correct answer. How much is the relative motion between P and Q? I think both the particles are moving with same velocity. So relative motion is 0. If the relative motion between adjacent fluid particles is 0, so continuous deformation will be 0. है ना? How do you write tau? Tau you write it as mu du by dy, where du by dy is the continuous deformation. That is relative motion between adjacent particles. So that relative motion is 0. Therefore this value is 0 and tau value is also 0. So between these two particles there is no friction force. There is no shear stress. Similarly, for Q and R, there is no friction. R and S, no friction. S and T, no friction. So these particles will move ahead without any friction, without any change in velocity. So obviously, these particles, when they will reach here, just before the plate, their velocity will remain unchanged. And how much is the velocity? 10 units. 10 units. This is the velocity of fluid particles just before reaching the plate. ठीक है ना? So suppose I write a 5 value here. So what is the meaning of 5? The meaning of 5 is when the particle crosses this point, it crosses the point with the velocity of 5 units. So basically the 10 means when particle is crossing this particular point, it is crossing the point with the velocity of 10 units. So basically in the figure I am showing the velocity at a point. So I am showing a Eulerian figure. I am showing velocity at a point. That is Eulerian figure. Now what will happen? As soon as these particles will move ahead, particle P will come in contact with the solid. And immediately, because of no slip condition, it will come to rest. So as soon as particle P comes ahead, the P particle will come in contact with solid surface, and because of no slip condition, its velocity will become 0. So all these particles, all the particles which are in contact with solid surface, their velocity is 0. So at these points in contact with the surface, velocity value is 0. That's why I've written 0 everywhere. Now check. Initially, when PQ are here, there is no relative motion. So between them, there will be no shear stress. So if there is no shear stress, the Q particle will move freely without any friction and without any change in velocity. Similarly, R particle will move freely, S particle will move freely, T particle, U particle, no change in velocity. But as soon as particle Q reaches over here, particle Q and particle P, they have a relative motion, and because of the relative motion, there will be continuous deformation in the fluid, and continuous deformation means that the viscosity will result in shear stress. So on particle Q, because it is moving fast, the shear stress will act in backward direction. And on particle P, the shear stress will act in forward direction. Now because of the shear stress, the particle Q will slow down. So when particle Q will move ahead, its speed will decrease. So as the particle Q moves ahead, because of the frictional stress, its speed will keep on decreasing. I hope it is clear up to here and no one has a doubt. Now particle Q and R, when the particles are here, they do not have a relative motion. If they do not have relative motion, there is no shear stress. So between Q and R, there is no shear stress. So R particle will move ahead without any friction. So its speed will remain the same. But as soon as particle R comes ahead, there is a relative motion. So friction will come between them. And because of the friction, particle R will also start slowing down. So when the particle R will move ahead, because of the friction, its speed will decrease. And in a similar manner, you can complete the remaining figure also. Sir, P will hold Q and R. P will hold Q and R will try to take Q ahead. हाँ, मतलब ये बात सही है. So you guys, you know what Abhash is saying? Abhash is saying, sir, this is particle P, this is particle Q, and this is particle R. So because of R, we can see, say for example, here we can see, say for example, here, okay? So what will happen? R is moving fastest. So on R, there is some shear stress in backward direction. है ना? There is some shear stress in backward direction. Who will apply this shear stress? Q will apply this shear stress. So what will happen? Action-reaction pair. Similarly, between Q and P, there is a shear stress. So, but Q is moving faster with respect to P. So on Q, the shear stress will act backwards, and on P, the shear stress will act forwards. Now let us call the two shear stresses as tau 1 and tau 2. Now there are different situations. So on Q, there is a tau 1 value in forward and tau 2 value in backward. If tau 1 is equal to 2, balance out. So Q will move with the same speed. Like that happens like should happen in a developed flow. If tau 1 is greater than tau 2, then the value of Q will keep on increasing. And if tau 1 is less than tau 2, then value of Q will keep on decreasing. So there can be different scenarios. ये तो बस एक्सप्लेन करने के लिए इस तरह से दिखा देता हूं, ठीक है ना? तो सिनेरियो कोई भी हो सकता है, एक्सेलरेशन का भी हो सकता है, कांस्टेंट स्पीड का भी हो सकता है और डी एक्सेलरेशन का भी हो सकता है. तो उसमें आप टाउ 1 और टाउ 2 को चेक करोगे और अगर प्रेशर फोर्सेस इन्वॉल्व हैं तो प्रेशर फोर्सेस भी लगाओगे. समझ आया भाष? इज इट क्लियर बेटा? ये वाला जो मैं फिगर बनाता हूं ये विदाउट प्रेशर फोर्सेस के बनाता हूं बिकॉज इन अवर ब्लेसियस सॉल्यूशन प्रेशर फोर्सेस आर नॉट देयर. Anyone with a doubt like Abhash? Anyone with a doubt? Anyone with a doubt? And I hope if this is clear, then we can complete the figure. So what we are doing is, we are showing that as the particles move ahead, then because of viscosity, because of external shear stress, because of the shear stress, how the velocity of particles is changing. Kindly check if there is any doubt in this figure. If there is any doubt in this figure, please do check. Please do check. Kindly check, please. Kindly check. Kindly check. Abhash, Sachin, कोई भी डाउट हो? आई थिंक मोस्ट ऑफ यू हैव डन दिस फिगर अर्लियर विद मी, है ना? तो शायद इतना प्रॉब्लम नहीं आ रहा होगा. लेट मी डू इट. लेट मी डू वन थिंग. लेट मी कॉपी पेस्ट द फिगर ऑन द नेक्स्ट स्लाइड. ठीक है? So guys, what we are doing is, so water is moving over the plate, and what we have done, we have shown what is the value of velocity at a point. And how we have shown this? That when water moves ahead, the lowermost layer of the fluid will come in contact with the solid surface. It will achieve no slip condition. So it will be immediately at rest. Now the upper particles are moving with some velocity, so there will be a relative motion. And when there is a relative motion, when there is a continuous deformation, then because of viscosity, internal stress will come into picture. Now this will slow down the second layer. But initially, second and third particle were moving with same velocity. So when particle 2 slows down, between 3 and 2 there is a relative motion. So there will be a shear stress which will slow down the third layer. Similarly, third layer will slow down the fourth layer and so on. So this is what is happening, and I hope this is clear. Now, let me do one thing. Let me take two cross sections. Okay, let me take two cross sections. Say for example, let us take a cross section over here. तो मैं better color use कर लेता हूँ. Let us take a cross section over here and let us take a cross section over here. So there are two cross sections. One cross section is at a distance x1 from the leading edge, and similarly other cross section is at a distance x2 from the leading edge. Now for both the cross sections, we are going to draw the velocity profile. Say for example, section 1. So at section 1, topmost point, what is the velocity? 10 units. So there will be an arrow of 10 units. Second point, what is the velocity? 10 units. Third point, 10 units. Fourth point, 10 units. But if you will go below, what is the velocity at this point? 9 units. So a smaller arrow. And what is the velocity at this point? 0 units. So 0 arrow, 0 length. So what will happen? The velocity profile will look like this. Similarly, for the other cross section, what is the velocity here? 10 units. So I will draw an arrow of 10 units. Velocity here, 10 units. Arrow of 10 units. But now if I go down, velocity here is 9, 8, 7 and 0. So what will happen? The velocity profile is going to look something like this. कुछ ऐसा velocity profile दिखाई देगा. A ऐसा. Correct? Correct? So this is how you can show the velocity profile at any section. Now let me do one thing. Let me draw a clean figure in the next slide. And I will show only these two sections. I will not show the remaining figure. I will only show the velocity profile of the three sections which are visible. One section is before the plate. Second section is 1 and then section 2. Okay? So what we have the plate in the 2D figure. We have the plate in 2D figure. Just one moment. ये क्या हो गया? Like this. So we have the plate in 2D figure. Water is approaching the plate and it is approaching the plate with a uniform velocity. So if we take a cross section before the plate, on this cross section, everywhere the velocity is same. On the cross section, everywhere the velocity is same. So if I will draw the velocity profile will look like a straight vertical line. And when I will take a cross section over here, this is how the velocity profile looks like. So for some points, the velocity profile is a straight line and then there is a curvature like this. Then I will take one more cross section. For the cross section, initially the velocity profile is like this and then the velocity profile goes like this, right? This is what we have shown. This is what we have seen. Now, say for example, if I consider section 1, for section 1, I hope you are able to identify a particular point, this one. let us call this point, say for example, क्या बोले इस point को, PQRS कुछ भी बोल देते हैं, H बोल देते हैं, चलो ठीक है, H, randomly H. So I hope you can observe that there is a point H. What is the meaning of this point? The meaning of this point is, if above this point I take any point, if above this point I take any point, so basically whatever is the distance of the point from the bottom, it does not matter, but because at all the points the velocity value is same, which is u naught, that is 10 units. So you will say above point H, above point H, above point H, above point H, at any point the velocity value does not depend upon the distance of the point from the bottom, and at the point velocity is u naught. But if you take a point below H, say for example here, so this is a point at a distance y1, so what is the velocity? u1. Then there is a point at a distance y2, what is the velocity? u2. So more is the value of distance, more is the velocity. So you will say below point H, so you will say below point H, if we take any point below point H, if we take any point, the velocity at the point depends upon the distance of the point from the bottom. So more is the value of the distance, more is the value of velocity. In a similar manner, you can identify a point H for section 2 also. Again, what will happen? For section 2, if you will take a point above H, then all the points have same velocity. But if you will take a point below H, more is the distance of the point, more is the velocity. है ना? So same thing will happen for section 2 also. So like this, every section will have a point H. So what we can do, using the H points of the section, we can draw a locus like this. So what I have done, every section has a point H and I have drawn the locus of the H points. Please note, this locus is not the path of a particle. This locus is an imaginary line. Above the imaginary line, we call the flow field as free stream region. Which region? Free stream region. This region is called as free stream region. And below the imaginary line, we call the flow field as boundary layer region. Boundary layer region. Boundary layer region. In the free stream, if you take any point, the velocity at the point is u naught, and the velocity does not depend upon y distance from the bottom. So you will say in free stream region, whatever is the point, the velocity at the point is u naught. It does not depend upon distance of the point from bottom. But if we take a point in the boundary layer, we also know if more is the distance of the point, more is the velocity. So within the boundary layer, the velocity at a point is a function of distance of the point from the bottom. So this is what a free stream is and this is what a boundary layer is. They are nothing but two regions. They are nothing but two regions. And how do you differentiate them mathematically? If the velocity at a point depends upon the distance from the surface, boundary layer. If it does not depend on the surface, then free stream region. Is it clear to everyone what a boundary layer is? Is it clear to everyone? I hope this is clear to everyone and no doubt is there. I hope this is clear and no doubt is there. So now what you can do, you can show a simple figure. Now you can show a simple figure. What the simple figure will say? Simple figure will say, let us suppose there is a flat plate. Let us suppose there is a flat plate. And water is approaching the plate with a uniform velocity u naught. This velocity is also called as free stream velocity. So what will happen? As soon as the fluid reaches the surface, the bottommost layer of the fluid will stick with the surface. This bottommost layer will slow down the second layer. Second layer will slow down the third layer. As a result, what will happen? We will see an imaginary line. This imaginary line divides the flow field into two regions. One is boundary layer and other one is free stream. So if you will take a cross section which is at a distance x from the leading edge, and for the cross section, if you will draw the velocity profile, this is how the velocity profile is going to look like. So in the free stream, any point on the cross section, it has the same velocity u naught. But in the boundary layer region, the more is the distance of the point, more is the velocity. So mathematically you say free stream means u is equal to u naught. It is not a function of y. And boundary layer means u is a function of y. Now obviously you can see in the free stream region, there is no relative motion between the adjacent particles. So du by dy is 0, which is specified from here also. U is not a function of y. So du by dy is 0. Once du by dy is 0, tau value will become 0. So in the free stream, the flow is non-viscous. In the free stream, the flow is non-viscous. So what will happen? If you will like to apply Bernoulli's equation in the free stream, that is possible because Bernoulli's equation is defined for non-viscous flow. But in boundary layer, two adjacent particles, they have a relative motion. So du by dy not equal to 0. And this is true also because u is a function of y. If du by dy not equal to 0, then tau value not equal to 0. So basically in the boundary layer, you will see stresses, viscous stresses, shear stresses. So in the boundary layer, the flow is viscous in nature. So in the boundary layer, you cannot apply your Bernoulli's equation because Bernoulli's equation is defined for ideal fluid. So this is what the definition of free stream and boundary layer is. So I think we should write some English also. इससे related थोड़ा सा English भी लिख लेना चाहिए because then the notes will also look complete. So what you can write like this. ऐसे आप लिख सकते हैं, ठीक है? So what you are going to write, you will write when a fluid flows over a surface. When a fluid flows over a surface. The layer of fluid. Now you will ask me, sir, what is the meaning of layer? What is the meaning of layer? देखो, layer का मतलब होता है whenever you define the layer of fluid. The layer means something which has the order of surface roughness of the surface. So suppose you have a surface, okay, and the roughness of the surface. So the roughness of the surface is of the order of 0.1 mm, okay. So this is the order of layer which we are talking about. So this is the layer which will form no slip condition. And I hope you remember when you say a fluid particle, it has a size of 1 micrometer. So even this term is 100 times the size of a particle. Even this term is 100 times the size of particle. ठीक है? तो इसको लिखने की जरूरत नहीं है, but आपकी knowledge के लिए. So when a fluid flows over a surface, the layer of fluid adjacent to the surface, sticks to the surface. Adjacent to the surface sticks to the surface. Sticks to the surface because of no slip condition. Sticks to the surface because of no slip condition. Because of no slip condition. So once this layer sticks to the surface, then because of viscosity, the shear stress comes into picture, which slows down the second layer. Then second layer will slow down the third layer. है ना? So sticks to the surface because of no slip condition. So you can write this layer slows down. This layer slows down the second layer. This layer slows down the second layer, which slows down the third layer, and so on. This layer slows down the second layer, which slows down the third layer, and so on. Third layer, and so on. Yes, there is boundary layer formation. तो अभिनव आभाष बेटा अभी वो बाउंड्री लेयर के वीडियो में हमने एक क्वेश्चन भी किया जिसमें दो बाउंड्री लेयर फॉर्मेशन हो रही हैं. तो जब विंड ब्लो कर रही है, एक बाउंड्री लेयर फॉर्मेशन फ्रॉम द ग्राउंड और दूसरा बाउंड्री लेयर फॉर्मेशन फ्रॉम द सरफेस ऑफ द बिल्डिंग. अभी क्वेश्चन किया ना, ये मैंने डे बिफोर यस्टरडे वाले वीडियो में किया है, शायद अभी 2-3 दिन पहले ही किया है. वेरी गुड, नाइस पॉइंट. थर्ड लेयर एंड सो ऑन. So you will write as a result, we observe an imaginary line, which divides the flow field into two portions. Imaginary line which divides the flow field into two portions. Divides the flow field into two portions. Into two portions. ठीक है? So what are those portions? Those portions are free stream region and boundary layer. Free stream region and boundary layer. Free stream region and boundary layer. ठीक है? So what we will do, we will write down the definition of free stream region. तो आप क्या कह सकते हो? आप कह सकते हो free stream region is the region of flow away from the surface. है ना? Check for yourself. So free stream region is away from the surface. So free stream region is away from the surface. It is the region where velocity at a cross section is uniform. Every point on the cross section has same velocity. ठीक है? And for boundary layer, you can say it is the region of flow which is adjacent to the surface where the velocity on a cross section is non-uniform. है ना? तो इस तरह से definition बन जाएगी. So I think let us write this definition. हम इस definition को लिख सकते हैं. So when you will say free stream, so you will say free stream. So I am writing free stream as Fs. So free stream is the region of surface. Free stream is the region of flow away from surface. Region of flow away from surface. Where velocity at a cross section is uniform. Away from surface where velocity at a cross section is uniform. Velocity at a cross section is uniform. At a cross section is uniform. ठीक है? So this means u is not a function of y. It is same everywhere, which is u naught. And when you will talk of tau, this will be 0. Also, as Abhash has mentioned, so you will learn later on that the flow in free stream is irrotational. Flow in free stream is irrotational. This you will learn later on. Okay? So for now, this much is sufficient. So you can also write tau equal to 0. Therefore, non-viscous flow. Non-viscous flow. So whenever the flow is non-viscous, so in fluid dynamics, we are going to learn two equations, Euler's equation and Bernoulli's equation. So when the flow is non-viscous, we can solve the flow by those two equations. Okay? Next, boundary layer. So guys, this will be the last definition for today. Actually, I have received the message. I have to take an interview in 5-10 minutes. ठीक है? तो वो इंटरव्यू भी जरूरी है, किसी का इम्पोर्टेंट इंटरव्यू है, 1-2 दिन से एक्सटेंड हो रहा है. तो आज मैं जल्दी 3:30 पे रैप अप कर रहा हूँ. और आभाष बेटा, आप मेरे से सेपरेटली भी डाउट पूछ सकते हो. 4:30 बजे फोन करके भी डाउट पूछ सकता है. ठीक है? फोन कर लेना. अगर 4:30 बजे नहीं तो 5 बजे मेरी क्लास है और मैं रात को 9:30 बजे फ्री होऊंगा, तो उसके बाद भी पूछ सकते हैं. So where was I? Boundary layer. So you will write boundary layer is the region of flow adjacent to surface. region of flow adjacent to surface. Region of flow adjacent to surface, where velocity at a section is non-uniform. Where velocity at a section is non-uniform. Where velocity at a section is non-uniform. At a section is non-uniform. Okay. So here you will write u is a function of y. So velocity in x direction is a function of y distance. So longitudinal component, longitudinal velocity is a function of transverse distance. Okay. Therefore, tau value is not equal to 0. Flow is viscous, and later on we will learn that flow is rotational as well. So check guys, clear or not? So I hope guys this is clear. ठीक है, आज के लिए बस करते हैं, and I will see you in the next class. So next class we will continue from here. We will see some important terms related to boundary layer. So what is boundary layer thickness? What is shear stress? Wall shear stress? Skin friction coefficient? Drag force? Drag coefficient? And we will see some very good questions related to this one. ठीक है, तो आज के लिए चलते हैं. There is some important work right now. तो मेरे को 5 मिनट में ही चेक करना है. तो मैं आपको अगली क्लास में मिलता हूँ. ठीक है, थैंक यू सो मच. सी यू इन द नेक्स्ट क्लास. बाय बाय.